Somewhere above your head, right now, the universe is hiding a door. Step through it, and you can never come back. Not you, not light, not even time, the way you've always known it. It's the most extreme object physics allows to exist, and tonight, we're going to do the one experiment no human could ever survive. We're going to fall in, together. Here's the strange part. A black hole is not a cosmic whirlpool roaming space and swallowing worlds. Stand far enough away, and it behaves like any other heavy object. You could orbit it safely, forever. The danger only begins at one specific line. So picture a ship, and picture you inside it, pointed straight at one. Over the next few minutes, we'll cross that line step by step. And I promise you, what happens to you, and what your friends back home would see, are two completely different stories. Let's begin where the idea itself began. In 1915, Albert Einstein rewrote gravity, not as a force, but as a shape. Mass bending the very fabric of space and time. Within months, a German physicist named Karl Schwarzschild solved Einstein's brutal equations. And he did it from the trenches of the First World War while serving on the Russian front. His answer contained something even he found troubling. Squeeze enough mass into a small enough space, and you create a region where the bending becomes infinite. A place gravity never lets go. For decades, physicists assumed nature would never be so cruel as to actually build one. They were wrong. That line we're falling toward has a name, the event horizon. And here's the first shock. It isn't a surface. There's nothing there to hit. No wall, no shimmer, no warning light. It's simply the distance at which the escape velocity, the speed you'd need to climb back out, reaches the speed of light. Below it, to leave, you would have to travel faster than light. And nothing can. That's the whole secret of why a black hole is black. Light itself falls in and cannot climb back out. And the strangest thing of all? If the black hole is big enough, you could cross this line, the most important boundary of your entire life, and feel absolutely nothing. But whether you cross it in comfort depends entirely on size. Gravity pulls harder the closer you are. 4 feet. First toward a small black hole, one a few times the mass of our sun, and your feet are yanked far harder than your head. The difference is so violent it stretches you into a thread of atoms. Physicists gave this a almost gentle name, spaghettification. Around a small black hole, it would tear you apart long before you ever reached the horizon. But fall toward a giant, a supermassive black hole, millions of times the sun's mass, and everything changes. Its horizon is so vast that the pull on your head and your feet is nearly equal. You would sail across it whole, alive. Still watching. So let's fall toward a giant. Let's cross. Now reality splits in two. To your friend, watching safely from a distance, something impossible happens. As you approach the horizon, your clock appears to slow, your falling body seems to freeze, your light stretches, reddens, dims, and you hang there, fading forever, never quite crossing. From the outside, you never fall in. You simply slow and redden and vanish, frozen at the edge of time. This is gravitational time dilation, and it is real. The stronger the gravity, the slower time runs. But you, inside the ship, you feel none of it. Your clock ticks normally. You cross the horizon without a sound, and when you look back, the entire universe behind you compresses into a single, brilliant ring of light, the whole history of the cosmos crowding into your rear window. Ahead of you, only darkness. And now you are trapped, not in space, but in time. Every direction you can move, every possible path, leads deeper in. Falling forward is no longer a choice. It is the only future that exists. At the center waits the singularity, a point where our equations predict infinite density and simply stop working. Here is the honest truth science rarely says out loud. Nobody knows what's there. Our best theory of gravity and our best theory of the very small flatly contradict each other at that point, and we have never had an experiment to settle it. A black hole isn't just the end of a journey. It is the literal edge of human knowledge, drawn in gravity. For a century, this was all mathematics. How could you ever photograph a thing that swallows light? Then, in April 2019, a planet-sized network of telescopes called the Event Horizon Telescope did the impossible. It revealed a ring of fire around a shadow. The supermassive black hole at the heart of a galaxy called M87, 55 million light-years away. 3 years later, they turned the same eye on the monster at the center of our own galaxy. Sagittarius A*, 4 million times the mass of the Sun. And the astronomers who first proved that monster was real, tracking stars whipping around an invisible giant, Reinhard Genzel and Andrea Ghez, were handed the Nobel Prize in physics. The door in the sky wasn't a theory anymore. We had its photograph, and here's the final twist, the one almost nobody expects. In 1974, a young physicist named Stephen Hawking proved that black holes are not truly eternal. At the very edge of the horizon, the strange rules of the quantum world let them leak the faintest whisper of energy. Slowly, unimaginably slowly, over spans of time that dwarf the current age of the universe, a black hole evaporates. It shrinks, and in a final flash, it's gone. The most powerful object in existence has an ending too. So after all of that, what is a black hole, really? Here's the uncomfortable secret we still don't fully know. 50 years after Hawking, his information paradox still burns. When a black hole evaporates, what happens to everything that fell in? Physics insists information can never truly vanish, yet the math says it does. So some theorists now suspect there may be no true singularity, no hard edge at all. That a black hole is really a tangled ball of strings they call a fuzzball, or that the collapse stops at what's known as a Planck-star, leaving a tiny remnant behind. Future file. Pure speculation. A few even wonder if those remnants could be the dark matter holding galaxies together, or whether each black hole hides a doorway to something entirely new. We built the mathematics to find them. We are still building the mathematics to understand them. So, what if you fell into a black hole? Near a small one, you'd never make it. Gravity would unravel you first. Near a giant, you'd cross a silent, invisible line, watch the whole universe fold into a ring of light behind you, and fall toward a mystery our finest physics cannot yet describe. And to everyone you left behind, you would never fall at all. You would simply hang there glowing, frozen at the edge of forever. The most extreme place in the universe is out there right now, keeping it secret. And the most extraordinary thing of all, we are a species of stardust that learned to photograph the invisible and do the math on the end of eternity. Keep looking up. Follow the prime's signal.